Dear students, in this video lecture we are going to learn how to resolve a force into three components when projection line is given. Case 1, you can observe that a force F we have to resolve along the x-axis, y-axis and z-axis. The component of the force with xyz axis are Fx, Fy and Fz. To resolve this force F with respect to xyz axis, when projection line is given, few points you need to identify. The very first point is find the angle made by the force with any axis or any line. Force F in this case made angle with y-axis, therefore along the y direction there is a cos component, but y-axis and this projection line is perpendicular to each other, therefore the remaining component of this F with respect to theta will be resolved along the projection line and it will be F sin theta along the projection line. Next point you have to observe in which two axes the position of the projection line is given. So projection line is defined in between positive x and positive z. So therefore in this case the component F sin theta is as a force defined along the projection line. Then find out the angle of projection line with any axis. In this case, the projection line has made an angle alpha with the x-axis and along the projection line there is a force F sin theta. So the components of F sin theta along x-axis is F sin theta cos alpha and the remaining component along the z will be F sin theta into sin alpha. Remember, in this case, a cosine direction is defined with y-axis, therefore y component for that cos theta is. Projection line is between x and z direction, therefore I have defined this with arrow, and with this case I have said this is F sin theta magnitude along the x and z line. And the x and z line has made x and z line, for that a projection line having angle with x axis, therefore along the x axis there will be the cos alpha and along the z axis there will be sin alpha. With this case we can say a force with angle y axis. But if in case of the force having cosine direction with the projection line, so then how we can define the components of the forces? See, the force with projection line angle made, it is theta. Now to this case, force and projection line, with that the cos component of force along the projection line. Projection line and y-axis perpendicular to each other, therefore along the y-axis there will be F sin theta. Second point you have to observe, projection line. Projection line is in plane x and z. Therefore, projection line along that the component F cos theta will be acting as a force. This F cos theta, to define in xz plane, we have to find out the angle of this projection line with x or z. So find here with which axis the projection line has made an angle with z. So this F cos theta as a force will define along x-axis as F cos theta into cos alpha, and along the x-axis it will be F cos theta into sin alpha. So see here the division of the same. Projection line has made an angle with the force, therefore I have defined cos components along the projection line and the remaining component perpendicular to the projection line is F sin theta. projection line is in between the axis x and z. So therefore, in this the angle of this the angle of this projection line with z axis is given. Therefore, along the z axis with respect to alpha it is cos alpha, along the x axis it is sin alpha. In this manner, we have to see the numerical related to this topic, resolution of force when projection line is given. The numerical on this topic, resolution of force in the space when projection line is given. Determine components of 6 kN and 4.5 kN forces as shown in the figure below. Also find angles theta x, theta y and theta z with coordinate axis. The figure is defined in that the force 6 kN is defined with projection line. Force 4.5 kN defined with projection line. The angles are defined for the force and the projection line. The angle of the force 6 kN is defined with y-axis and the projection line also. So separately if I draw a sketch of 6 kN force, so then you can observe its diagram here. And now you can see how I have defined the components. 3 points you have to ask to yourself. सबसे पहला point आपको ये देखना है कि 6 kN फोर्स ने किस एक्सिस के साथ एंगल किया है. तो 6 kN ने एंगल किया है y एक्सिस के साथ, इट इज 25 डिग्री. y एक्सिस को यहाँ पे परपेंडिकुलर कौन सा लाइन है, तो ये प्रोजेक्शन लाइन है. तो इसके अकॉर्डिंगली cos component along the y-axis and sin component of 6 kN along the projection line. With this case, we can say that the f6 cos 25 is acting along the y-axis and 6 sin 25 acting along the projection line. Then find the projection line in between the two axes. The projection line is in between the axis positive x and positive z. So ये आपका फोर्स बन गया 6 sin 25 इन प्लेन x एंड z. तो ये फोर्स ने अब देखो किस एक्सिस के साथ एंगल किया. इन दिस केस 6 sin 25 a force has made an angle 30 degree with x axis. तो इस फोर्स का x के अलोंग कंपोनेंट हो जाएगा cos 30 and with z axis the component will be sin 30. See here the forces I have represented along xyz direction. Force का angle with y axis, therefore along the y axis it is 6 cos 25 and projection line is in between x and z. Therefore, I have defined this line for this. And now, this projection line along, we have defined the component 6 sin 25. Therefore, 6 sin 25, 6 sin 25 we have defined. Now, projection line का angle with x-axis है, इसीलिए x-axis के along cos 30 हो गया और z-axis के along sin 30 हो गया, क्योंकि projection line किन दो axis के बीच में है, x and z. Now, the same way we can say that the magnitude of the force 6 kN having components along x, y, z are fx, fy and fz in this manner. We know that theta with its cosine direction defined as fx cos inverse of fx upon f. Theta x is equals to fx is this 2.196 upon magnitude of the force is 6 kN. So angle will be 60.5 degree. Theta y cos inverse of fy upon f with that 25 degree. Theta z cos inverse of fz upon f, it is 77.8 degree. Now this is the case in that we have defined 6 kN force with a projection line and a particular cosine direction. Now second case, in that you can see that a 4.5 kN force has made an angle with the projection line. With this projection line, the angle of this 4.5 kN is given as 35 degree. Now, it means that this projection line and the y-axis is perpendicular. So first of all, with respect to projection line and the angle given between the force and projection line, we have to resolve the component of force 4.5 kilonewton. So projection line के साथ एंगल है, इसीलिए it will be 4.5 cos 35 और y-axis के लिए हो जाएगा 4.5 sin 35. Then observe that projection line किन दो एक्सिस के बीच में है. तो प्रोजेक्शन लाइन यहाँ पे आप देख सकते हो, ये है पॉजिटिव z और निगेटिव x के बीच में. सो व्हेन the force component 4.5 cos 35 is acting along the projection line, so then we have to define this force magnitude in between negative x and positive z axis also. So find projection line का एंगल किसके साथ है. सो यहाँ पे projection line का एंगल with z axis है. तो ये फोर्स ने 4.5 cos 35 फोर्स ने किसके साथ एंगल किया, z के साथ. तो z के अलोंग कौन सा कंपोनेंट हो जाएगा, 4.5 cos 35 इंटू cos 40 एंड निगेटिव x के अलोंग कौन सा कंपोनेंट हो जाएगा, 4.5 cos 35 इंटू sin 40. So with this case the components are expressed as for the 4.5 kilonewton force. So fx, fy and fz. सबसे पहला पॉइंट, फोर्स ने किस एक्सिस के साथ एंगल किया, प्रोजेक्शन एक्सिस के साथ. तो प्रोजेक्शन के अलोंग कॉस कंपोनेंट. सो वी हैव डिफाइंड प्रोजेक्शन लाइन. प्रोजेक्शन लाइन किन दो एक्सिस के बीच में है, निगेटिव एक्स एंड पॉजिटिव जेड. सो निगेटिव एक्स एंड पॉजिटिव जेड आई हैव डिफाइंड विद दिस एरो. सो इसके अलोंग कंपोनेंट बन जाएगा माइनस 4.5 cos 35 प्लस 4.5 cos 35. देन इंडिपेंडेंट कंपोनेंट इज 4.5 sin 35. कोसाइन डायरेक्शन के अकॉर्डिंगली कंपोनेंट्स लिखकर हो जाने के बाद आपको ऑब्जर्व करना है प्रोजेक्शन लाइन किस दो एक्सिस के बीच में है. तो x, निगेटिव x और z. सो निगेटिव x और z में से किसके साथ प्रोजेक्शन लाइन ने एंगल किया है, z के साथ. तो z के अलोंग cos 40 और वो कितना एंगल है, 40 डिग्री. तो cos 40 अलोंग द z एक्सिस, sin 40 अलोंग द x निगेटिव x एक्सिस. तो कंपोनेंट बन गए हैं fx माइनस 2.369 किलो न्यूटन, fy प्लस 2.581 किलो न्यूटन, fz 2.823 किलो न्यूटन. फॉर द मैग्नीट्यूड ऑफ फोर्स 4.5 किलो न्यूटन, द कोसाइन डायरेक्शन इज theta x is equals to cos inverse of fx upon f. It becomes 121.76 degree. fx comes as negative. Substitute the negative value only, because with negative axis we have to find out the direction of the force 4.5 kilonewton. Theta y is equals to cos inverse of fy upon f. It is 55 degree. Theta z is cos inverse of fz upon f. It will be 51.15 degree. With this case, we have seen in this numerical how to resolve a force into three components when a projection line is given. I hope you have cleared the concept, but before ending this video lecture, I would like to tell you 3 points. The very first point in this numerical you have to see. The very first point is फोर्स ने किस एक्सिस के साथ या किस लाइन के साथ एंगल किया है वो देखो. सेकेंड पॉइंट, प्रोजेक्शन लाइन किन दो एक्सिस के बीच में है दिया हुआ वो देखो. और थर्ड पॉइंट, प्रोजेक्शन लाइन ने किस एक्सिस के साथ एंगल किया है वो देखो. विद दिस 3 points you can find out the components of a given force in the space force system with the projection line. I hope you have cleared the concept of resolution of force in the space when projection line is given. Thank you.